Welcome to fourth episode of our monthly webcast series, Aftermarket Intelligence Unlocked. I'm Chetan Shah, I lead program manager management at Tawant, and it's fantastic to have you join us today. Every last Friday of the month, we spend 30 minutes hearing from industry experts about what's changing, what's working, and what's next in the aftermarket space. Before we dive into AI agents, a couple of quick housekeeping points. This webcast is being recorded and you'll receive a playback copy afterwards. We also encourage you to ask questions. Use Q&A button at the bottom of your screen to type your questions, and we'll get to those as many as we can at the end of the session. Today's discussion centers around how agentic AI ingests real-time IoT error codes and maintenance data to automatically flag service needs, open support cases, and guide proactive dealer outreach. By surfacing the right opportunities at the right time, AI agents help dealership grow revenue and keep the equipment running at its peak uptime, helping improve customer satisfaction. Joining us today is Sarah Ledford, Knowledge and Data Development Manager at Kubota Tractor Corporation. Sarah and I have collaborated for our past 5+ years to deploy analytics and AI-driven solutions to improve product quality, give dealers visibility into telemetric data, build agentic AI capabilities to automate service workflows. I'm Chetan Shah. I lead program management at Tawant, where I oversee global aftermarket engagements and seamless delivery of AI-powered maintenance platforms. So over to you, Sarah.
All right. Well, thank you so much for that introduction, Chetan. Just wanted to say quick, there is a survey poll going on. So feel free to go ahead and look at that during our discussion today. And then we can also deep dive into those questions at the end. So, but welcome from Texas here. Again, my name is Sarah Ledford, Knowledge and Data Development Manager at Kubota Tractor. And I just wanted to share some of, really what we're looking at today as some of the challenges as we're talking in this realm and for the potential that we have. So first off, the challenges, let's start off there. Right now we have really large economic shift happening, of course, with, we are coming out of the COVID era and now, rising interest rates, shifting demand in terms of our consumers and customers and what they're looking for in our equipment, right? Then also that also leads to challenges with our dealer network that we would like to, of course, address and understand. One of the things that we do see is missed service calls or missed service opportunities. That could be just due to challenges in communications in your traditional sense of, voicemails, missed calls, proactively picking up the phone for service, right? That does lead to lost revenue. Traditional models are reactive support models, right? It does rely on the customer knowing what's wrong with their equipment, articulating that correctly to the dealer, and then the dealer having the knowledge on their side to be able to address those problems on the machine. And then, of course, human-only diagnostics. You think your traditional, technician, wrench turner, right? That relies on a lot of, learned expertise for that individual. And then once they leave the shop, that knowledge leaves as well. So that is some challenges that we are looking to come up with solutions for in the AI realm. So AI-powered solutions, and again, we're exploring a lot of these today, but then there's also future opportunities and growth that we're excited on the potential there. So revenue diversification. Of course, when you buy a tractor, that commission is one time, but then when you have service that is repeating, that is additional revenue that you have moving forward. And then also when they buy that second tractor or sell that tractor, that secondary customer, right? So there's a lot of exploration we're looking at there. Automated service alerts, that's something that's really exciting. So instead of relying on the customer to know what's wrong with the machine and then taking the time to call up the dealer or maybe try to service it on their own, the machine itself can say, hey, I am having a problem, right? It can communicate to that dealer directly and not rely on the customer making that outreach, right? But then also that's valuable for us too at a corporate level to understand if many machines are operating with a certain failure type, right? We can go downstream with quality, we can have parts out ordering, there's a lot of potential there. Usage-based maintenance. So not just with hours of use or your standard service time, or you have on your typical automotive, you repair or get an oil change every 2,000 hours, maybe 5,000. That's a typical, hour-based metrics we use in the tractor industry. But what if we can do maintenance based off of how the equipment is being used individually by that customer? So maybe they have high loads, high RPMs, or there could be some additional signals that we can pick up from that machine and then cater maintenance to that particular unit. Failure and warning alerts, automated technician support tickets as well. So again, instead of somebody having to physically be on the phone and taking the information from that customer, if the customer even indeed knows how to articulate it, we can have the cases automatically generate for service engineers that support the dealers, have it automatically entered. That happens today. AI suggested repairs as well, based off of either how that machine itself is behaving, but also analytics from other machines that have failed in similar fashions, what was taken to repair that machine. So I want to pause there and remind everybody we do have a Q&A chat. So if you have any questions about what we're talking about, please feel free to use that and we can address those as we go on. So, all right, so Chetan, let's kind of dive into this and conversationally. We're talking through, what we're able to do today, and then kind of what we're imagining in the future too.
Absolutely. So before we get into the future, we have had a pretty nice journey over the past few years. So one of the basic questions a lot of people are having these days, as we talk to a lot of our customers, is a lot of organizations are collecting a lot of IoT data, but struggle how to get started in making sense out of this data and utilize it in a productive way. Can you tell us about your journey, how you got from, let's say, having your equipments fitted with sensors and modems and get raw data, troves of data, to where you are today?
Yeah, I would say it's number one, we just had to start somewhere, right? How are we going to get the data off this equipment? And that's really been a 5-year journey on our side. But I would say let's, take it in bite-sized pieces. Look at the obvious stuff that like really just being able to read the error codes that are coming off of the CAN bus system, right? And being able to put that in some sort of centralized location, right? And transmit that information, right? So just get that process started. So we do have technology teams, smart folks. I'm not in that team. They just are able to get it going for us. But us on the service side, we are able to consume that information. But yeah, so that would be. It's been like a 5-year journey on that front. We constantly are discussing with those the software engineers that have the modem installations themselves. But I'd say a big thing too is talking with the design engineers for the product itself, right? Because they might not be supporting a certain signal currently, but it's something that they can plan for and design later down the road. So I think it's constant communication with various teams and them understanding what is the need on the service side and supporting the dealers and diagnostics, right? I'd say that's a big thing is communication and then just taking things one bite at a time. Yeah.
Yeah, that's really helpful. And as you were talking about maintenance opportunities, proactively telling the dealer or even the customer about upcoming maintenance. So with the solutions that you have enabled for the dealers, how are the dealers utilizing the maintenance opportunities presented to them that is enabled through the IoT data?
Yes, so with the modem signals that we're sending to a centralized database, we were able to build a dashboard for service, for the dealers, It could be a service manager, or maybe they want to have a designated person at the dealership. And what we do is we have their entire inventory for anything that they've sold, and we can show them, hey, you have your 500-hour maintenance, about to come up, and maybe the unit is at 450 hours, right? So we can, you have a maintenance opportunity, right? And you can, either way, they have various methods that they do like to communicate with their customers, and we let them do that. But ultimately, instead of them waiting on the customer to call them up, we have all of it centralized in one location, so it's really easy, more like a customer resource management. It's not that, but it's more of a dealer maintenance opportunity. So it's not just maintenance as well. It can be other types of outreach that they would need to do to that customer, and having it all be centralized in one location versus across multiple softwares. So I think that was a big win there.
Yeah, I think the other softer side of it is more around maintaining that customer engagement after the initial sale happens, because generally, some of this equipments that Kubota, is doing business in, customers like farmers and construction companies, they keep these machines for a very long time. So this kind of allows them to build that ongoing engagement so that they could, come back for future purchases, or, utilize Kubota dealers for, doing their services. So, our focus today is more around Agentic AI. So tell us how Agentic AI is transforming the technical services operations. That's something probably going to be a lot more interesting for everybody to hear.
Oh, absolutely. So I did allude to it earlier as well in the automatic case creation. For those that aren't familiar with the tractors or construction equipment, they generate error codes themselves, right? And what we can do is transmit those into our case system. And based off of various knowledge articles that we have about those error codes, right? And it might be multiple error codes that could also, have a different type of solution if they're exhibiting at the same time, right? Being able to present that to the dealer in a live case, automatically created, so that they can already start down the diagnostic path even before talking to a single person, right? So I think that's really interesting because ultimately, machine downtime, every dollar counts for that customer, right? Especially in our rental fleets, right? Construction equipment is a really big, every minute that machine is down is costing the customer money. So the faster that we can get information using, again, the Agentic AI systems that we put in place, getting the right information at the right time to be able to diagnose and repair that machine is critical. I'd say another portion of it too is having the right parts. That, we saw during COVID, supply chain issues for everybody across the globe, right? So the faster that you can understand your demand and be able to order, said parts, or understanding that, hey, I'm having an uptick, maybe some sort of quality issues happening, whatever it may be, but having that initial, or that additional time to be able to feed even that information to our warehouses. And actually, if you could, we touch on that on the next slide a bit too. So we did, but since I'm going into that as the answer, so with the technical case, right, being able to provide via the Agentic AI failure prediction likelihoods too. So based off of the error codes coming in from the machine, you can say, okay, it's 80% likelihood that this is a fuel pump problem, right? Then also, or it could be 20% the fuel injector, right? So you're presenting that diagnostic result probabilities to the dealer, right? And then the dealer can also discuss that with their customer as well. And then also parts needed to repair. Okay, if you need a fuel injector, you need to flush out, or whatever it would take to repair that machine, right? We can have that. So from there, and this is a concept, we aren't there yet, okay? So, but the idea is having the warehouse be notified via this AI system as well. Like, hey, you're going to start to get an uptick or additional demand for these fuel pumps, right? And then even further yet, be able to, within certain triggers, right, ship those parts automatically to the dealership. And this would all happen before even the customer contacted the dealership, right? We can have all the way downstream communication and AI driven, and it's very exciting on our side. So.
It is certainly is very exciting. I mean, it's so fun to see all this happen in real world. Doesn't, I mean, it used to feel like, it's like a futuristic thing, but it's that future is today. And, forward-looking companies are jumping into the AI phenomenon and, reaping that benefit. So, of course, it's a lot of hard work, but it does so many things to improve the efficiency of the business operation. Um, so having said that, I mean, where else do you see future of agentic AI in the aftermarket space? I mean, we did talk about like product services. What else do you see where you could leverage some of these capabilities to make things even better for the dealers and the customers?
Really excited to learn is where the AI can uncover maybe patterns of machine usage or signal types that aren't so obvious to the engineers, right? To be able to more so on the predictive maintenance level. That's where I'm truly excited in that front. And then again, as we continue to work with our design engineers and get additional data signals, we have more that we can feed into it. But I mean, if you have a machine that has 50 different signals, I mean, just as a human alone, you really can't be analyzing that. Or maybe there's some NASA scientists that can, but for practicality and some of for us, we're not advanced statistics, mathematics scientists, right? We need to be able to lean on that AI and detect these patterns and predictive events or predictive failures before they even happen, right? Maybe we can replace that fuel pump before we let it fail, right? So that's I think the biggest thing, and ultimately the future is there is no downtime really. That the AI is able to have the machines continuously. Well, I mean, you're going to have to replace that. You're going to have to take it out, but really the part is there right on time. You have minimal downtime. Maybe it's like a half of a day to replace that versus waiting for it for 2 weeks and delivering it in the shop and stuff. So that's where I see some really great AI journey direction for us. I think the industry is going that way, but we're really just excited to put it in place. So.
Okay, so we do have a first question coming through the Q&A chat. So it's more kind of technology driven, as a lot of this requires quite a bit of technology investment. So the question is, how do you balance the trade-off between data quality and volume against the storage cost and projected ROI when designing your AI data pipeline?
So the phrase that we commonly use is like, okay, you can have data, but if it's bad data, there's no point in using it. So that I would say that's a really bad or a challenge, right? So and sometimes your CAN bus or the modem is it will give you bad data. Just like a fuel pump failing, like I keep saying, or an injector. So that's definitely a challenge. And that's where I see AI also helping us too, is being able to say like, look, this doesn't seem like this is a normal behavior for this data or the tractor to be giving to us, right? It's not, it's reading sporadic hours, right? So it could actually sense or alert us too that the data being transmitted is not that good, right? Don't use it, don't consume it. And I'd say a bigger challenge too is, of course, more data, the better. Everybody wants all the data, right? So, but then you have to store that physically somewhere. So for us is saying, can we design these systems to consume less data? Because then again, you don't have to store all of that and incur that cost. I mean, I could have every single second gathering all 50 signals off of that machine, or can I be all right with every 5 minutes? Or maybe the fuel level, it's all right to know like every 10 minutes, but I want to know the engine RPM every second because that's more critical for some maybe cumulative load calculations, right? So I think it's understanding what you really need to be capturing more fast or quicker versus things that you don't need to be as much, and then going from there. But everybody always says, oh, I just want all the data. Well, that's not practical because the storage is just, I mean, you have thousands and thousands of machines in this field. You can see how that can really add up. So.
Okay, that's really good to know because these are some of the this is a lot of new ground that people are exploring, and it's good to know what are the lessons learned, sort of thing. What is good to do, what is to avoid. So thanks for clarifying that. Couple of more questions. This is more related to security. I think there is a lot of potential in AI, but at the same time, a lot of organizations are concerned about the security aspect of it. So the question is on the lines of, what strategies have you found most effective for meeting stringent security requirements when accessing and using internal data for AI projects?
So I'd say number one, of course, any internal, with big companies such as ours, we have our internal security and group. It's in the IT department, and I'd say keeping them 100% involved in the conversations about what you're wanting to do, what are they comfortable with, what documentation do you need, what steps do you all need from us so we can properly plan and get that for you, right? I'd say another thing is right when AI first came out and it really started blowing up. It took me like it's becoming like buzzword. Everybody's talking about it. About a good year and a half ago. So what that did was for IT departments, it kind of freaked them out. Like, oh no, what do we do? And they just no, nothing. We aren't allowed to use any of it before we get a handle on it, right? And so I think that as it's not becoming as so new, and they're realizing this is a reality that we need to be working in to be competitive. We're going to have to start working and figuring out this technology and making sure that, again, constant communication. But us on the business side, we say we need this and we need this yesterday. So I think that's a big challenge too. But that's their role, is to protect us and our data integrity, and so we work really closely with that.
Yeah, that's really important, security. And we got one more. What approaches do you use to break down data silos and streamline data maintenance workflows to support scalable AI implementation?
What's interesting for us is there could be data being gathered by, within the software platform, and then another software over here, and that we could be helpful for the AI to know both of them and being able to consume both of those, data. And it could be multiple sources. So I'd say developing a centralized data database, like a service data lake or some sort. That's what we call it. To be able to bring in all of those data information, so it's not siloed across multiple parts of the organization anymore. So having a bigger, longer term strategy around that, I think, is very important. For us, multi-corporation, we have multiple sites all internationally. is knowing, okay, these people have this information. Why are we also maintaining this information over here? Why can't we work together? So I think like just bringing all the data to be able to be consumed by the AI, that's, I think, the biggest challenge and direction to have to go.
Yeah, so what we are seeing is that a lot of companies struggling with AI projects because of this reason. Disparate data, inconsistent data where the same thing is called or recognized differently across different parts of the company or different systems. So one of the critical factor for driving of success of the AI projects or any other enterprise level project is to address your data challenges. What I mean by that is that uh, you know all the data should be either consistent or should be able mapped in a way where data is easily interoperable and can be utilized. You can bring in data from multiple sources. You can bring it from old mainframes or some of the new cloud systems, and maybe sometimes it's even coming from an Excel or Access database, and merge together to actually make sense out of it, to make it more effective. I think we are coming up top of the hour. It looks like there are no other questions coming in, so we can wrap up. So, Sarah, thanks a lot for your invaluable insight today. It was very, informative, and thank you everyone for joining us today. We hope that this session was useful for you and gave you some good insight into what's possible today, what could be possible tomorrow, and what things you need to count for to make it a successful journey into the agentic AI world. And we look forward to seeing you for the next episode, number 5 in July. And have a great day and a great weekend. Thank you.